The wiring diagram shows that there is no yellow wire connected to the pump. The yellow wire in the control box is used for a single-phase pump. In this case, the pump is a three-phase pump. To wire the pump, firstly, connect the black and red wires from the pump to terminals B and R in the control box respectively. Secondly, connect the green wire from the pump to the ground terminal in the control box. Thirdly, connect the LON and L2 terminals in the control box to the 240 volts feed from the electrical panel. After the pump is wired, connect the pressure switch to the control box. The pressure switch will turn the pump on and off as needed to maintain the desired water pressure in the system. Let's delve a bit deeper into the electrical principles at play here. A single-phase motor receives power through two wires, typically labeled as LON and L2, or sometimes hot and neutral. The voltage between these two wires provides the energy needed for the motor to operate. In contrast, a three-phase motor uses three wires, each carrying an alternating current that is out of phase with the others. This configuration provides a more consistent and efficient power delivery, making three-phase motors well suited for demanding applications such as well pumps. The Franklin Electric control box is designed to manage the starting and running of the well pump motor. It contains capacitors and other components that help to provide the necessary starting torque and protect the motor from overloads. The LON and L2 terminals on the control box connect to the 240 volts power supply. These terminals provide the main power to the control box and, subsequently, to the motor. The B, Y, and R terminals are connected to the motor windings. The letters B, Y, and R typically stand for blue, yellow, and red, respectively, and they correspond to the three phases of the motor. However, in this case, the pump only uses the B and R terminals, indicating a specific wiring configuration for the three-phase motor. The green wire is the ground wire, which provides a path for electrical current to safely return to the source in the event of a fault. The ground wire is connected to the grounding system of the electrical panel, ensuring that any stray voltage is quickly dissipated, protecting both the equipment and the people who may come into contact with it. The pressure switch is a crucial component of the well pump system. It monitors the water pressure in the system and automatically turns the pump on and off to maintain the desired pressure range. The pressure switch is typically wired to the control box in such a way that when the water pressure drops below a certain threshold, the switch closes, signaling the control box to start the pump. Conversely, when the water pressure reaches the upper limit, the switch opens, causing the control box to stop the pump. Wiring the pressure switch correctly is essential for the proper operation of the well pump system. It is also important to ensure that the pressure switch is properly calibrated to the desired pressure range. The specific wiring diagram for the Franklin Electric control box provides detailed instructions on how to connect the pressure switch. When working with electrical wiring, it is always essential to take appropriate safety precautions. Firstly, always turn off the power to the circuit before working on any electrical components. Secondly, use insulated tools to prevent electrical shock. Thirdly, wear appropriate personal protective equipment, such as safety glasses and gloves. Also, double-check all wiring connections to ensure that they are secure and properly insulated. It is also important to consult with a qualified electrician if you are not comfortable working with electrical wiring. They can provide expert guidance and ensure that the wiring is done safely and correctly. In addition to the basic wiring connections, it is also important to understand the operation of the Franklin Electric control box. The control box contains several components that are designed to protect the motor from overloads and other faults. These components include capacitors, overload relays, and fuses. The capacitors provide the necessary starting torque for the motor, while the overload relays protect the motor from overheating. The fuses protect the circuit from short circuits and other faults. Understanding the operation of these components can help you troubleshoot any problems that may arise with the well pump system. If the well pump is not working properly, there are several things to check. Firstly, check the power supply to ensure that it is turned on and that the circuit breaker has not tripped. Secondly, check the wiring connections to ensure that they are secure and properly insulated. Thirdly, check the pressure switch to ensure that it is properly calibrated and functioning correctly. Also, check the control box components to ensure that they are not damaged or faulty. If you are unable to diagnose the problem, it is best to consult with a qualified electrician or well pump technician. They have the expertise and equipment to diagnose and repair any problems with the well pump system. In summary, wiring a well pump control box involves connecting the pump wires, the power feed, and the pressure switch. The yellow wire is not needed for a three-phase pump. The black and red wires from the pump connect to terminals B and R in the control box, respectively. The green wire from the pump connects to the ground terminal. The LORN and L2 terminals connect to the 240 volts feed from the electrical panel. The pressure switch is wired to the control box to turn the pump on and off as needed. When working with electrical wiring, it is essential to take appropriate safety precautions. Consult with a qualified electrician if you are not comfortable working with electrical wiring. Remember to always de-energize the circuit before beginning any work. Following these steps will ensure the well pump system is properly wired and operates safely. It's also crucial to refer to the specific wiring diagram for the Franklin Electric control box model being used, as there might be slight variations depending on the model. The wiring diagram will provide the most accurate and up-to-date information for the specific control box. Furthermore, proper grounding is paramount for electrical safety. The ground wire provides a low resistance path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. Ensure that the ground wire is securely connected to both the control box and the grounding system of the electrical panel. The size of the wire used for the well pump circuit is also important. The wire must be large enough to carry the current required by the pump motor without overheating. The National Electrical Code, or NEC, provides guidelines for determining the appropriate wire size based on the motor's full load amperage and the length of the circuit. Consult NEC Table 310.15b16 for ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees C through 90 degrees C. The pressure switch settings also play a crucial role in the well pump system's performance. The cut-in pressure is the pressure at which the pump turns on, and the cut-out pressure is the pressure at which the pump turns off. These settings should be adjusted to provide the desired water pressure in the system. It is essential to avoid setting the cut-out pressure too high, as this could damage the pump or the plumbing system. Additionally, consider installing a check valve in the well pump system. A check valve is a one-way valve that prevents water from flowing back into the well when the pump is turned off. This helps to maintain pressure in the system and prevent the pump from cycling on and off too frequently. Lastly, proper maintenance is key to ensuring the longevity and reliability of the well pump system. Regularly inspect the wiring connections, pressure switch, and control box for any signs of damage or corrosion. Replace any worn or damaged components promptly. By following these guidelines, the well pump system can be wired and maintained for years of reliable service. Remember that local codes and regulations may vary, so consult with a qualified electrician or inspector to ensure compliance with all applicable requirements. Let's also consider some common troubleshooting scenarios. If the pump is not running at all, the first step is to check the circuit breaker. If the breaker is tripped, reset it. If the breaker trips repeatedly, there may be a short circuit in the wiring or a problem with the pump motor. If the pump is running but not pumping water, check the well for sufficient water level. Also check the pump intake for any obstructions. If the pump is cycling on and off too frequently, check the pressure switch settings and the condition of the pressure tank. A waterlogged pressure tank can cause the pump to cycle excessively. If the water pressure is low, check the pressure switch settings and the condition of the pump. A worn or damaged pump may not be able to generate sufficient pressure. When troubleshooting any electrical equipment, always prioritize safety. Turn off the power to the circuit before performing any inspections or repairs. Use insulated tools and wear appropriate personal protective equipment. Consult with a qualified electrician if you are not comfortable working with electrical wiring. The control box typically includes overload protection, which is designed to protect the motor from damage due to excessive current draw. The overload protection device will trip if the motor draws too much current for an extended period. If the overload protection device trips, it is essential to determine the cause of the overload before resetting the device. Common causes of motor overloads include low voltage, excessive load on the pump, and a faulty motor. If the motor is overloaded, it may be necessary to reduce the load in the pump or replace the motor. Also, consider the environmental factors that can affect the well pump system. Freezing temperatures can damage the pump and the plumbing system. Protect the pump and the plumbing from freezing by insulating them or providing heat. Lightning strikes can also damage the well pump system. Consider installing a surge protector to protect the system from lightning strikes. The location of the well pump control box is also important. The control box should be located in a dry, protected area where it is easily accessible for maintenance. Avoid locating the control box in areas that are prone to flooding or moisture. Proper ventilation is also important to prevent the control box from overheating. The control box should be installed in a well-ventilated area to allow heat to dissipate. The wires that connect the pump to the control box should be properly sized and insulated. Use the appropriate type of wire for the application and ensure that the wire is properly protected from physical damage. The wire connections should be tight and secure to prevent loose connections, which can cause overheating and electrical problems. Regular inspections of the well pump system can help to identify potential problems before they become major issues. Inspect the wiring connections, pressure switch, control box, and pump for any signs of damage or corrosion. Replace any worn or damaged components promptly. Clean the pump and the control box regularly to remove any dirt or debris. By following these maintenance practices, the well pump system can provide years of reliable service.